Welcome to lesson 4, example number 6, and it is asking us to design or select the lightest pipe column and the lightest square tubular column that can safely support an axial load of 250 kips, which we put right there, and then the unsupported length is 20 foot and K equals 1, so it's most likely a pin-pin type connection. And this is pretty simple because if you have a steel book, you just go into the necessary design section, which hopefully you should just take a second and look those over and possibly tab them, because it can be confusing. There's a lot of them, and I would rather tab them ahead of time, and then when you get there you'll know exactly what you're looking at, as compared to going in and looking at it and wondering what exactly it is and possibly making mistakes, selecting the wrong section, maybe unsupported and supported. There's a lot of information on there, and I think you should go up there and take a look. Anyways, these are in the AISC manual, of course, and it wants us to go in there and figure out select what section we want, and then we're going to start in the standard steel pipe, and that is on. Well, they produced it below. Tell you what, I'm going to go get my steel book. 2 seconds. Alright, I now have my steel book, and oddly enough it was in a drawer of my nightstand next to my Bible, so they call it the Steel Bible, and apparently I took it a little too literally. Anyways, moving right along, we need to turn to page 336 in the steel manual, and it says column standard steel pipe, allowable concentric loads in kips, and it says up in the left hand corner it says Fy equals 36 KSI, and that's what we want because all of these are assumed to be 36 KSI. That was said at the beginning of the chapter. Anyways, what we need to figure out is KL it says effective length in foot, KL with respect to radius of gyration, and we have a KL equals 1.0 is our K, and then our L, or unbraced length, is 20 foot. So we have a 20 foot, alright, or 20 I guess, and we go in and we look for which one. I guess you go down. It's kind of hard since I don't have it diagrammed here, but you go down on the left side where it says 0, 6, 7, 8, 9, and so on, and you go down to 20 because that's what our KL is in foot, as it asks to your left, and then you just want to go to the right and say, okay, what is the lightest section I can use, given that it actually has enough capacity for 250 kips. And it looks like on there they have gone and used the 261. So 20 and you go up, it's 12. Nominal diameter of 12. And the wall thickness is 0.375. And the weight per foot is 49.56. So 49.56 times 20 foot times 20 foot equals 991. So let's see if that's the lightest. Where else can we get 250? Let's go over to the 10, nominal diameter of 10, and see if that works. Okay, up at the very top you can see if we use a nominal diameter of 10, you can actually get 257 kips out of there. So let's see. Oh, never mind. That's at 0 KL. Okay. So yeah, we just stop there, and we're good. So we go ahead and select that. We go 20, then we go over to 261. If we go any further, it's 201, and that's less than 250, so we want to go back to 261. We go up, and it says nominal diameter. It's 12. And that's a standard steel pipe. STD steel pipe. And I guess we could look at extra strong. Extra strong. Let's try to do the same thing and see what happens. So if we go into KL is 20. That's on 3-37, and I probably should take a look and see if they just wanted to use normal or extra strong. Anyways, we're going to do it real quick. and that's standard steel pipe. We'll go in and say, okay, we have a 20 KL. We go to the right, and it would be 10-inch diameter, which has a 0.5 inch wall thickness, which its weight per foot is 54.74 times 20. This is standard steel, and it would be a 10-inch diameter extra strong. How should I write that? Extra. Let's write it out. Strong pipe. And this is what? 54.74 pounds per foot times 20 foot. And this one up here is, what did we say? 49.56. Times 20 foot. Since they're the same, you just see which one's bigger or which one's smaller, and that's what you want. And this will be smaller, so it'll be lighter. So we don't want to use the 10-inch extra strong pipe. Going down to 10 inches diameter, got a smaller pipe, but it actually weighs more because the walls are thicker. All right, so that's our pipe answer. Is we wanted to use a 12-inch diameter standard steel pipe. Now let's continue on to, they also asked to find a structural tubing. And we'll go to there. And one quick note is that if you'll look at these columns, structural square structural tubing, you'll notice that the FY actually equals 46 KSI, which is a little bit different from what we've been dealing with, but I guess that's they only use 46 KSI for the structural steel tubing. And the question, or the problem, example number 6, didn't really specify what KSI it is, so we'll just go ahead and assume that's correct and move on. And we do the same type of thing. We already know our KL. We go in over at 20, and we begin going to the right. And on this first sheet, 3-39, it's actually the 12 by 12, 16 by 16, and 14 by 14. We need to keep going because the smallest 12 by 12 is a 3/8-inch wall, and that gives you 386 kips. So let's go to the next page, which is 3-40. Go down, KL equals 20, and you just continue to go to right. And we actually have 251, and that is a 10 by 10 with 5/16 inch thick walls. And that gives us 251. So let's go ahead and use that. And what do we say? We said 10 by 10 times 5/16. Square, that's not square. Square structural tubing. And that would be our answer for the, not the pipe, but the tube part of the question. And unlike the pipe example, they could do extra strong. There isn't an equivalent that I'm aware of the extra strong tubing. That's kind of how they do standard pipes. And as architects, I guess you guys probably use a lot of handrails, and a lot of handrails use tubing. So that hopefully that makes sense to you. They have extra strong, I think extra strong. And thank you for paying attention. I hope that makes sense to you. If you have any questions or comments, please go ahead and feel free to write it down, or go ahead and post that, and hopefully I can get back to you. Alright, thank you very much. See you on the next video.